So of course, once you have posted, meaning created, meaning inserted, a new document, at least in the path we're taking to the API here in this course, at some point you'll likely want to update that document. Let's take a look at how we do that in Couchbase and also a bit about why it happens so fast. So there's a fundamental difference between the architecture of an old-style RDBMS and a modern system like Couchbase. In a traditional RDBMS, as data comes in, it is written to disk first. Then it's logged for availability, and then an index is updated in memory. What this means is that because only the index is in memory, virtually all reads and writes must perform a disk seek. Now, by contrast, Couchbase takes a memory-first approach. The genetics of Couchbase are in the memcached product. It's always been a memory-first product. As your data comes in, the data is immediately cached in memory. It's then replicated for availability, and yes, it is written to disk, but all your reads and writes can be served immediately from memory. That speed difference can be critical in a lot of modern applications with millions of customers or millions of devices reading and writing data continuously. So how do you go about replacing an existing document? Well, again, it's done through the bucket, and the bucket supports a replace operation, and you pass the replace a key and the item. Now, this does do a full replacement of the document. Subdocument updates are also supported by Couchbase as of 4.5 and higher, and if you're working with very large documents, that might be a better solution for you. If you're working with smaller, more granular documents, as we are here, the replace approach may be as performant as you need. So, in the update, you would want to update your entity values, like update updated to the current date and time, and then you would also possibly be working with type prefixing, so you would pass the value through to ensure that it has the correct type prefix on the key, because you have to update the document by its key, and then you get back a result as before. If that result is successful, great. If not, well, if you're trying to update a document that does not already exist in the bucket, well, then you're going to get a document does not exist exception and handle that as appropriate for the application that you're building. So let's summarize what we've looked at so far, because there's maybe a little lurking issue in here you haven't thought about yet. We create documents by inserting a key in an item. Does that key already exist? Well, we get an already exists exception. So if we do a read, well, I get a key. If the key isn't there, I get a does not exist exception. Update. Well, if I want to update, then I do a replace, pass in the key and item, and if the key isn't there, again, a document does not exist exception. Well, so that means you're having to keep track in every operation. Am I doing a create? Am I inserting a document, or am I doing an update? Am I replacing this document? Do I have to keep track of which one those are, and how much complexity could that create on the client, particularly for a high-speed, high-ingestion application? Well, we've got a solution for that. Stay tuned. It's in the next lesson. So in the lab, we're going to walk you through updating an existing document, and for the education of seeing it, walk through trying to update a non-existent document to set you up for a learning point in the next lesson. So we'll use the replace operation inside of an update operation. When you're done with that, come on back and we're going to take a look at something called an upsert. Stick around.